Hello! Okay, today we're talking about 1.2, which is visualizing our relationships in data, which means we're going to be building graphs. So we talked about one variable data and two variable data. Specifically, two variable data is used to find correlations between the data. So we had two sets of data for the same cities. We had the population and we had the population density. And so from that we can construct a table, which generally a table is going to be in terms of variables x and y. Now, the way in which we typically think about these is x is an independent variable and y is somehow dependent on that variable if there is a correlation between them. But right now we're just talking about data. So we're just taking some data samples x and some data samples y, and then we're going to plot them and see if we see any correlation between them. So we put the data in. So for example, what I will do is take the population data for my x and I will take the population density data for my y, and then what we will do is plot them on a graph, which usually is going to take the form of a vertical axis that corresponds to our y data. That's supposed to be an arrow. And a horizontal axis that is our x data. So for each x point here, it will correspond to some point along the x-axis, which will correspond to some y. I guess I'll use a plus, right? So if that corresponds to this y value, then I would track that over, track that up, and I would have 1 point there for that data. This will construct what we refer to as a scatter plot. So hold on. Alright, so if we build the table, we have population for our x column and we have population density for our y column. I've color-coded the dots so that you can easily correlate what to what when you're looking at these things. And then I plotted them on some rough sketched axes here. So you can see very clearly that there's this grouping of data over here in this population, and then it decreases for the two in the middle and then increases again because Denver has such a high population and also such a high population density, showing that there isn't any correlation. It doesn't trend down, it doesn't trend up. It's kind of goes down and then it goes up. It's not telling us anything specific to correlate these two sets of data. Another example that we will look at is has a correlation that we all know. That's altitude in meters and pressure in atmospheres. So I put together a table of data. So obviously if you are at 0 meters of altitude, that's sea level, then the pressure is defined to be 1 atmosphere. Now as you go up in elevation, you see that the pressure decreases. So when we do the scatter plot for this data, we will see a trend of it decreasing because as you can see in the data, it decreases as, so P decreases as A increases, right? Now, one thing that I want to do a side note of is talk about ordered pairs for a second. Ordered pairs is used to define points on the graph in a standard notation that involves parentheses and a comma-separated value for each row of the table that we see here. So if I, for example, first look at when the atmosphere is 0, the pressure is 1. The ordered pair for that data point corresponds to 0, 1. So that means that the horizontal axis I'm at 0, and on the vertical axis I'm at 1, and that corresponds to the location of the point in this plot. So the ordered pairs for this coming from this table give me 0, 1, 1200, and 0.87, 2000, and 0.79, 3500, and 0.66, and then finally 5800 and 0.49. And these are the points that I'm going to plot in the graph. Now when we go to plot this, we can reference either the table or the ordered pairs since they are equivalent statements. Now the left column of the table is also corresponding with the first entry of each ordered pair, and the right column of the table corresponds with the second entry of each ordered pair. Now, the left column is corresponding with the x-axis, so that's the altitude measurement. The first entry of the ordered pair tells you where to go along the x-axis, and the second entry of the ordered pair, corresponding with the right column of the table, tells you where to go along the y-axis, or the vertical axis. So 0, 1 is already here. That purple blob comes from the first ordered pair, or the first row of the table. If we go to enter the second one, so 1200 will be slightly to the right of our 1000 mark, and the 0.87 will be about a tenth below the one on the y-axis. Is putting it somewhat about there-ish. Now 2000 we have a marker for, so we just go directly above the 2000, and then 0.79, that's about, 0.2 below R1. 3500 is going to be about halfway between 3000 and 4000, and 0.66 is going to be, 0.16 above the 0.5 mark, so we have to approximate where that is. It was a little low. Should be about there. So then if we go on to the 5800, that is slightly to the left of the 6000 mark, and our value is 0.49, should be right about on the 0.5. As you can see from these dots, there is a general trend that the function seems, or not the function, the scatter plot is decreasing, so there is a correlation between the data because each point gets lower and lower. As you go to the right, the points go lower. As you go to the left, the points go up. So since we are looking at this data as the altitude increases, the pressure decreases, which is what you would expect. If you know anything about pressure already, you know that as altitude increases, the pressure decreases. The last thing we have to talk about is domain and range. And domain and range will correspond to the values that we have in our table and in our ordered pairs here. So domain specifically relates to the values that are along our x-axis, or the values that are in the left column here, or the first entries of the ordered pairs. So our domain will be a list of those values. It must be in an increasing order. So we use what I call squiggly brackets, and then we comma separate each value. So the first value in this case is 0. Then we have 1200, 2000, 3500, and lastly 5800. For the range, we do the same thing, but for the y values. Now again, I have to put them in the increasing order. So notice that our values for the pressure decrease, which means that I'm going to have to flip their order in this case. 0.49, 0.66, 0.79, 0.87, and finally 1. Close. This is something that we'll come back to. We'll be using it a lot in the context of data, and then we will start using it again in the context of functions. So please let me know if you have any questions.